just change it. Okay, there's something that you enter wrongly. Okay, there's something that you enter wrongly, not by a few ones. So when we let, okay, when we let the displacement is equal to 0, what will happen? What do you get? Now, by the way, I have not a clue what you will get. Okay, I'm just asking you to do it. Okay, so, okay, the first person that get, I think if my wife is some money in my wallet. Sorry, the first person get it, you get a pint of beer from me, you can get it from ETB 216, okay? Tell me what you get. What do you get? Hey? Still loading. Still loading. What do you get? No. No? Not like that. Can you enter it again? No. How many of you know other software that could do it online? Is it WooFrame Captcha or WooFrame Alpha? What software do you use? Go into WooFrame Alpha, type it in, and what do you get? Any idea? Any ideas? What do you get? You're still thinking? You're still thinking? Oh, thanks off. Okay. Yes, off twice. Can you get anything? Yeah. 6 points? No, don't sound right at all. If you do it again? Yeah. How many? Okay, that doesn't sound right at all. Okay, what I'm going to do now, okay, now I realize that how many of you calculator tell you can't solve? How many of you? Okay, so I decided in the term test, if this question were to come out, okay, I will only mark your final form. Are we clear? Okay, I'm not going to penalize you. You're going to find that the T magnitude. Okay, because I think it requires a computer. Now, I'm going to talk to you a bit about the term test. The term test that you're going to have in the beginning of October, okay, you're going to have 3 questions, and it's going to be 2.5 hours. As you can see, how many questions? 3 questions, 2.5 hours. And the questions are going to be very similar to your homework. I repeat again, the questions will be very similar to your what? Homework. But I will make a twist. What is this twist? You cannot memorize your homework and go for the term test and pass. Okay? I might change the sign. Okay? Part of the constant is dependent on your student number. You get where I'm coming from? Okay, so you need to know your work. You don't memorize your Eugene say everything is coming from it. Yeah, it's very similar from the assignment, but I'm going to change stuff. I'll give you a quick example. I don't want you to panic. Okay, but I'll give you a very quick example. So if we were to look at if we were to look at a question like this, okay, a spring is stretched 200 millimeter, for example. So I can say a string is stretched by 1 AB. Okay, what does AB means? Your last 3-digit student number can be 451. This is A, this is B, this is C. So 1 AB for you, based on your student number, your constant will be what? 145. Are we clear? Okay, so this is how I'm going to tweak. Okay, and sometimes I can change this by I can change this and put this what? Upwards. Okay, so you need to know how to what? Manipulate. Are we clear? Okay, so but it's not something that you have not seen before. This is how I test. Same for this course, same for 3AO3. It's the same. Okay, are we clear? Yeah.
0.691.
Don't worry about it.
2.69.
Okay, don't worry about it. Okay. Okay. Thank you for doing it. Okay. Now, so I hope you were yes. Say it again. Yeah, so 451 is the last 3 digits of your student number. Okay, so you put in the constant accordingly. So don't memorize anything. You have to what? Understand and write summary sheet. Are we clear? And don't come out and compare with your friends. Okay, what's your answer? No, you are wrong. Come on, seriously, don't do that. Okay, right. Now we are going into a new, not a new topic, a subtopic. Okay, a subtopic, and the solution procedure is slightly different. Now, I have students in this class taking mechanical vibe. Yes. Say it again. If we were to look at the general solution, does that make sense? Okay. Right. Now, some of you are taking mechanical vibration in your 3rd year. Where are you? Where are you? Only one? What have you been taught? Have you been taught this yet? No? Not yet? So what you're learning now? Oh, introductory. Okay. We are going full speed, okay? But I hope this does this lecture help you all in your 3rd year? Okay, so some students over here who in their 3rd year are taking what? Mechanical vibration. What is that course called? 4Q03. You all will take this in your what? In your 3rd year. But whatever I teach over here, I will not delete. Okay, you can use until you graduate. Are we clear? Okay. So anything you don't understand, come back to this side. Are we clear? Okay, don't like we forget what Eugene taught. I'll be so pissed off. Okay, so come back, watch the videos. You'll be okay. Right. The next thing that I'm going to teach now, a subtopic, is known as force undamped vibration system. So what is different now is now there is a what? A force. It's no more a what? Free vibration. Before that, we have free vibration. So what does it actually mean? Physically, what does this actually mean? So what it means is initially, you have a structure and you attach a spring. Okay. Then after that, what we're going to do, so I like to elaborate. Okay. This is the initial position. Okay. When there's no mass. So what we are going to do next is we are going to put a load on it. Okay. We're going to put a load on it. And when you put a load on it, what will happen is your displacement changes. Okay, you can see your displacement changes. So for this case, what we are going to do is not just the displacement changes. We are going to put a force is equal to F0 sine omega t. it will always be a sine or a cosine. Okay, why is that? If you look at it in a perspective of a car, right? If the road is flat, we are okay, right? If the road goes up and down, up and down, up and down, right? It's a sinusoidal waveform. Okay, so this can be in terms of sine. I think it also can be in terms of cosine. Okay, so when you write the equation, the characteristic equation, it changes now. Okay, so if we look at the characteristic equation, so always remember the spring force. Okay, so Fs is equal to Kx, and Fs correspond to the spring force. So it's always in the opposite direction. Okay, so we declare x positive is coming down, right? So when we write this expression or the characteristic equation, is different. Okay, so what we have now is f naught sine omega t minus by kx is equal to mx double dot. Okay. So when we change or when we rewrite this, so you got mass x double dot, then plus by kx is equal to f naught sine omega t. Okay. I do apologize. There's a omega naught subscript naught. My bad. Can you put a naught, please? My bad. Okay. So this now becomes a what? Non-homogeneous equation. Okay. It's known as non-homogeneous because the entire function is not equal to what? 0. Only for that simple reason. So now when we rearrange this, we get x double dot plus by k over mx plus by f naught, not plus, equal to f naught over m sine omega naught t. Okay. So this is my equation number 1. Now, you will learn this in 2ZZ03. Okay. I only know the procedure, but I don't know why, or not I don't know why, I forgot. If I think I read the math textbook, I could remember. Okay, but for now, just follow my procedure. So for this case, we are going to have our complementary solution. Okay, we're going to have a complementary solution. So this is term x small c and is equal to c1 sine omega t plus by c2 cos omega t. Now, does this look familiar? It is exactly the same function when we have free vibration that is what? Undamped, right? So this is the same, the complementary solution is the same as free vibration, okay, or free undamped vibration, okay, free undamped vibration, okay. So the next step that they have is they let the particular solution be equal to xp, and this will be equal to x sine omega naught t. Okay. Why they select this? Because they know the system, right, will end up in what? A sinusoidal wave. Why? Because the force input is also what? Sine omega naught t. Are we clear? Okay. If it's cos, you use what? Cos omega naught t for the particular solution. Okay. So the first thing that we're going to do is we're going to differentiate x dot p. So this will be equal to x omega naught cos omega naught t. Okay. And then we differentiate again. X double dot p is equal to x minus now. Minus x omega naught squared sine omega naught t.